In this video, I will be going over solutions to worksheet 5 and how I got those solutions. We're going to start off with all of the evens on the front of the worksheet. So number 2 is magnesium chloride. I would like to get you a little familiar with what this page looks like before I go any further. All right, I'm always going to put the actual question up here at the upper left. You should have the same materials in front of you that I have up here on the board. You should have your periodic table. This looks a little different from the periodic table you have, but it's pretty much the same thing. I just color-coded it and put in my zigzag line to separate metals and non-metals. I also have down here the flow chart. I mentioned this flow chart a couple times in class. These flow charts can be found in the back of your packet. I'm going to be following through the flow chart and showing how useful the flow chart can be for how to do names and formulas. Remember, you shouldn't be memorizing the flow chart, but this is the decision-making process you should be using. I also want to point out on the top of the flow chart is going to be all about what kind of compound it is, and then the bottom of the flow chart is going to be about how to do names and formulas for ionic compounds. We know that molecular compounds and acids are a lot easier to name and do formulas of. Acids you just memorize, or you put hydrogen in front. That's an acid. A molecular compound, you just use the prefixes to come up with the subscripts. All right, let's start with number 2. I'm going to be following through the flow chart here. So first question, does the name contain prefixes like mono, di, or tri? If it does, it's a molecule. It doesn't, no. Let's go to the next question. Does the name contain acid? That would be a pretty good tip-off it was an acid. I don't see the word acid in magnesium chloride, so that's a no. So we're down to, in fact, it's an ionic compound. It has charges. All right, next one. Are there any Roman numerals? No, there aren't. Does the name end with 8-ite hydroxide cyanide, or does the name start with ammonium? That's a no also. So all you got to do is look up the symbols and charges of all the components on the periodic table. So I go up to the periodic table, Mg is here, Cl is here. So Mg is 2 plus and Cl is 1 minus. Sorry, I should write Mg first, Mg 2 plus. Remember, charges go up at top. They're superscripts. All right, now let's go down to the next question on the flowchart down here. Are the charges of the cation and the anion equal and opposite? I really should have the word opposite here. Equal and opposite. The word opposite is on your flowchart. In fact, they're not equal and opposite. Excuse me. They're not equal and opposite. So you got to crisscross the charges. 2 plus goes down there. 1 minus goes down there. It becomes MgCl2. Right? Remember, you don't write pluses or minuses at the bottom because they don't make any sense to be written at the bottom. The bottom is the quantity of atoms. And the top number superscripts are charges of each atom. All right, let's go to the next one. This is number 4. Potassium sulfate. Let's follow our flow chart. No prefixes. It's not an acid, so therefore it's ionic. You might want to put that in your little chart as you're asked what kind of compound it is. It's ionic. Are there Roman numerals? No. Does the name end with 8 hydroxide? Yes, in fact, the name ends with 8. So that means the compound contains a polyatomic ion, which you need to know or look up. Sulfate is on our polyatomic ions chart. It's SO4 2 minus. All right. Now we go back down here and look up the symbol and charges of all other components. Potassium's K plus. Are the charges of the cation and anion equal and opposite? No, they're not. So we have to crisscross. 2 goes down there. So it just becomes K2SO4. Remember, never mess with the subscripts on the polyatomic. So SO4 has to stay SO4. That's the formula K2SO4. Let's move on to number 6. So number 6 is sulfur hexafluoride. Does the name contain prefixes? Why, yes, it does. It has hexa in it. That means it's molecular. In other words, it contains only nonmetals. Has no charges. Write symbols for the elements, then write subscripts that match the prefixes. So symbol for sulfur is S. Remember, no charge. You don't have to look up 2 minus. Fluoride is F. Remember, no charges. You don't have to look up that it's minus. In fact, it's not minus. And then hexa belongs to the fluorine. No crisscrossing. The formula of this thing is just FFs, SF6. Remember, molecules have covalent bonds. They share electrons. There's no charges. There's no giving or taking electrons. None of the crisscrossing stuff works with molecules. They're really straightforward. It's only nonmetals. Notice both sulfur and fluorine are on the top right of the zigzag line. They're nonmetals. That's why we don't do charges. By the way, if you accidentally did charges, if you did S2 minus and F minus, notice two negative things can't be in the same compound together. They would repel each other. Let's look up number 8 here. Dichlorine heptoxide. Does the name contain prefixes? Yes, it does. It's molecular. Cl, di means 2. Hept means 7, and in front of oxide, so it's just 7 O's. So Cl2O7, done, easy. Notice we stop right here at the little stop sign. Let's move on to number 10, calcium chloride. Any prefixes? No. Any acid? No. Are there Roman numerals? No. Does the name end with 8-ite, hydroxide, or cyanide, or does the name start with ammonium? No. So all you got to do, it's a really simple thing, look up names and charges. Ca2 plus, Cl minus. Again, I just look up Ca and Cl, and then put the charges down. And then finally, are the charges of the cation and anion equal and opposite? That's a no, so you got to crisscross. They're not already equal and opposite. We crisscross to make them equal and opposite. Sorry. CaCl2, done. Again, the reason we're putting CaCl2 is because there are 2 negatives, and that will equal out the 2 positive charge of the 1 calcium. So 1 calcium atom, Ca2 plus, and 2 chloride ions, which are each negative. And notice that their total number of negatives is 2 negative, and the total positives are 2 positives. This is a neutral compound. It's also road salt. Let's go on to 12, lead 4 chloride. No prefixes, not an acid, so therefore it's ionic. Let's write that down, ionic. Roman numerals. Yes, in fact, there are Roman numerals. That gives you the charge of the metal. Notice we need a Roman numeral because lead, Pb, is in the column that we don't know what the charge is from the periodic table. If you're given the Roman numeral always refers to the top number, not subscripts. It refers to the top charge on the lead. In other words, in lead 4 chloride, it's lead 4 with chloride. The 2 parts of this compound are lead 4 and chloride. So lead 4 means the lead 4 plus ion. Chloride is still the Cl minus ion. By the way, we would go down here. No. Are the charges equal and opposite? Crisscross, because no, they're not. PbCl4. Done. Lead 4 chloride. Carbon tetrachloride, number 14. Prefixes? Yes, it's molecular. Cl is chloride. Tetra means 4, just like the video game Tetris. There are 4 blocks in every shape, and you want to make lines of 4, rows of 4. Aluminum sulfate. Let's go down the list. No prefixes, not an acid, so therefore it's ionic. Are there Roman numerals? No. Does the name end with 8-ite, hydroxide, or cyanide, or does the name start with ammonium? Why, yes, it does. It ends with sulfate, 8. That means we have to look up the common polyatomic ion. Sulfate is SO4, 2 minus, right? Look up the names and charges of all the other components. So the aluminum part, we need to look on the periodic table. Al is in the 3 plus column. All right, here we go. Are the charges equal and opposite? Why, no, they are not. So we got to crisscross. 3 goes down there, 2 goes down there. That's Al2. Right, what the heck do we do with 3? Well, we need to make 3 sulfates. We need 3 sulfates to be down here. But we can't mess with any of the current subscripts. So we protect our polyatomic with parentheses. We need 3 full sulfates. Here's what this means. We have 2 aluminum atoms. That's an aluminum atom, and it's 3 plus. And that's another aluminum atom, and it's 3 plus, and there's 2 of them. And then we have 3, count them, 3 sulfates. So that's SO4, 2 minus. That's SO4, 2 minus. And that's SO4, 2 minus. And there's 3 of them. And notice that 6 minus total and 6 plus total, the charges are equal and opposite. That's why this works. This is the answer. let's go to the next one. Potassium chloride. K, this one's easy. So K plus and Cl minus. Essentially, the way we go through this path is blah, 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 done. Blah. And then are the charges equal and opposite? Yes, they are. So don't write any new subgroups. It's just K and Cl. Copper 1 sulfide. All right. Does name contain prefixes? No. Name contain acid? No. Roman numerals? Yes. It gives you the charge of the metal. So copper is 1 plus. You can write 1 or you can just write plus, 1 plus. All right. Does the name end with 8-ite hydroxide or cyanide, or does the name start with ammonium? No. Be very careful. The name ends with I. This is sulfide. It's not sulfate or sulfite. Sulfide is just S from the periodic table. That's what this says. Look up the symbol and charges of all the other components on the periodic table. So now we got a crisscross. Cu2S is the final formula. And that's it. I'm going to do another video for the back of the worksheet.